Hi students, Miss Marta here. Today we're going to learn about the greatest common factor. So let's begin. Take out that notebook and we're going to open it up to the next new page. And on the very first line, the top line of the notebook, of the note page, we're going to write our date. All right, this is an example date. And then we're going to skip 2 lines and we're going to write the title of our lesson, greatest common, starting writing with my cursive F, greatest common factor, GCF. People often refer to it as the GCF. So what is the greatest common factor? Well, it is the largest number that can divide a pair or set of numbers. So to better explain what I mean, let's do an example. Let's start with 24 and 45. Okay, so what are the factors of 24? 1 times 24, 2 times 12, 3 times 8, and 4 times 6, and that is it. The next number I would have would be 5, but 5 does not go into 24 because it doesn't end in a 5 or 0. So that's it. Those are the factors of 24. If you notice, you can read them from least to greatest in this order: 1, 2, 3, 4, 6, 8, 12, and 24. All right, now let's cover 45. The factors of 45 are 1 and 45. 3 times 15 and 5 times 9. And those are the factors of 45. 1, 3, 5, 9, 15, and 45. Okay, so that covers the factors. Now let's cover what is common between them. So I'm going to take my little highlighter here and I'm going to circle the common factors. We got a 1 in both. We got a 3 in both. And the largest one is 3. So the GCF equals 3 because it is the largest common factor for both numbers. There you go. Here's a good point to pause if you need to pause and copy. All right. Going on now to our next example, I want to address the fact that when you're taking notes in a notebook for math, particularly for math, I'm going to show you my entire page. Okay, so right there. Okay, there's my entire page. If you notice, this is about the middle of the page, around there. And notice I'm already kind of past the middle, you look right there, I'm kind of past the middle. A rule of thumb that I have for note-taking, particularly in math, for a math notebook, is if I'm past the middle of the page, don't start a new example. Because you never know how long that example is going to be, how much space you're going to need to write that example out or to solve a problem. So sometimes it's just best to turn to the next page and begin the next example. There is nothing wrong with having more space and whiteness on the page where there's less notes. It's actually easier to read your notes when there's less on the page. So turn the page and let's go to the next one. And we are going to start talking about using prime factorization. Now, why am I talking about prime factorization again? Well, we learned it yesterday. And the reason we're going to use prime factorization as a method for finding the GCF is because sometimes the numbers are so large that they have so many factors it's too many to list them all. So the best thing to do is just use prime factorization. I'm going to give you an example here with, let's do an example here with, let me think of two big numbers. What about 72 and 96? They're pretty big. All right, 72, let's break that up. 72 is 8 times 9. 8 is 2 times 4. 4 is 2 times 2, and 9 is 3 times 3. So I can go, and I'm going to write here, 72 equals 2 times 2 times 2 times 3 times 3. All right, now let's look at 96. Looking at 96, I think, okay, I can divide this by 3, and that would be 3 into 32. And 32 is 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. All right, so let's look at 96. 96 is, so I'm going to count right here. 1, 2, 3, 4, 5 2s and a 3. 5 2s and a 3. So we got 2 times 2 times 2 times 2 times 2 times 3. Okay, great. I'm going to use my highlighter here, and I'm going to highlight what is common. So I have 2s, a pair of 2s, another pair of 2s, another pair of 2s, and I can do a pair of 3s. That's it. I don't have any more factors that are common for both sets, for both numbers. Okay, so that means that the GCF, is 2 times 2 times 2 times 3. So what is that? That is 4 times, that's 4 times 6. So that's 24. So 24 is the greatest common factor of 72 and 96. I can divide 72 and 96 by 24, each of them evenly. And that is the biggest number that will go into both. All right. I'm going to now just double check my work here because sometimes I just feel like that's important to do with math. So let's see. The 72 is 8 times 9. 8 is 2 times 4, and that's 2 times 2. That's 3 2s. And 9 is 3 times 3. So that is 1, 2, 3. And yeah. And 96 is 3 times 32. 32 is 2 times 16, 2 times 8, 2 times 4, and 2 times 2. That's 1, 2, 3, 4, 5, and a 3. 1, 2, 3, 4, 5, and a 3. So yeah, 2s, 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 then it would be a 3s. Okay, so notice double checking my work, always important, I think, and it only takes seconds to do. I think it's an important thing to do in math, and it should not be overlooked. Okay, again, looking at my page, notice I am beyond the middle of the page. So I am definitely going to have to use my next example on the next page. So, and that's fine. I'm going to turn to the next page for my last example. And we're now going to find the GCF of 18 and 35. All right, so let's look at 18. 18 is 2 times 9, and 9 is 3 times 3. And 35 is 5 times 7. So when I list it out, 18 equals 2 times 3 times 3, and 35 equals 5 times 7. And if you notice, there aren't any common factors. The only common factor actually is 1. And I'm just highlighting it there in blue so that you can see the GCF for these two numbers is 1. The GCF equals 1. That's the biggest number that can divide both 18 and 35. All right, so that is it for today. Again, I hope you enjoyed this lesson, and I will see you tomorrow for the least common multiple.